Hello there, and welcome to the test corrections for the Chapter 12 test. I am putting these up for you so that you are able to do your test corrections, and then the remediation assignment is a practice problem assignment. I'm going to put some things on the original test. Please remember all forms are the same, A, B, C, or D. Okay? And I'm going to do some things so that you understand the work that you were supposed to do, but I'm not going to do the work. So I'm going to explain it. I probably will say what you needed to do, meaning the sentence you're supposed to put, what you were supposed to do. In this problem, when you have a tangent line that touches a radius, you were supposed to know that the right angle marks go there. And then this is a four-sided figure, so you would add up all the angles to equal what measurement? Correct. The big thing is it's 360 degrees. Big thing is you would draw your own picture, and of course the central angle and its arc are the same, so that measurement that goes there should have been 154. Problem 2. Again, the radius touches a line that's tangent. You're supposed to put what here? Correct, a right angle mark. And then it's a triangle, so they know they all add up to equal, right. They give you an angle measurement that you're supposed to put in there, and when you add them all up, they equal to 180. Correct. Remember, there's the magic numbers 90, 180, 360. Okay, and most of this stuff was triangle work, or more specifically, right triangle work. So when we look at problem 3, it says AB is tangent, which means you would write a right triangle there, which means you can use Pythagorean theorem. They give you a measurement for here, they give you a measurement for here, and then they give you a measurement for here. You're supposed to know that you can do a squared plus b squared equals c squared, and whenever you find this whole measurement, you can just subtract 50 from it, and it will give you the radius, or the other piece. Okay, they want to know what AB is. Okay, so it's this squared plus this squared. Of course, you're supposed to know that this piece is 50, and the radius inside of the shape is the same. So if you know what AO is, you know what OC is, because they're both radius. So if you have this number and this number, what does it add up to? Correct. You'd add them together to get your hypotenuse. Correct. Then you do a squared plus b squared equals c squared to find out what AB is. Problem 4. Well, this was a right triangle problem, and it's in your notes. It is there. You'll see it in your notes. One of the sides of this triangle, and you'll have to look it up in your notes, but one of the sides in the triangle is from center to center. One of the sides of this triangle, and I gave you the diagram in your notes, so you'll have to go to the notes to find it. But I tell you, one of the sides is radius minus radius, one of the sides is center to center, and one of the sides is the chain. Okay, so that's your hint. This is in your notes, though, almost the exact same or similar problem. Remember, this would be considered the chain, and center to center is here. So one of the sides of this triangle is center to center. One of the sides of this triangle is the big radius minus the small radius, and one of the sides of this triangle is the outside chain or piece. And it is in your notes. Okay, problem 5. Tangent to the circle again, so you would put a right angle mark, and you would know that if you're finding lengths, it would be a squared plus b squared equals c squared. The key to this one is they give you a to o. They give you a to b, and they want you to find the radius. So a squared, b squared, there's your right triangle work. Hopefully you know which one is c squared. This dealt with all of these segments are congruent, so you just put the numbers on there and work your way around. Okay, that was the congruency marks you're supposed to add. So you'd put in the numbers, and then it's pieces by pieces. You got to do some adding or subtracting to find all the pieces. And then once you find all the pieces, it's a bimodular problem, which means you do 2 steps. So once you find all the pieces, you're going to find the perimeter, so you're going to add them all up. This is really good work for the EOC because it's very similar. Problem number 7 was that if the circles are congruent, and the angles are congruent, and the arcs are congruent, right? The problem is it's these arcs. So like, here's my central angle, then I know this arc is congruent to this arc. I know that this radius is congruent to this radius. Everything about the radius, the angle, and the arc are the same. The other arcs are going to be different. The only one you know is the same is the angle, the arc, and the radius that you're dealing with the two circles because they're congruent. Okay? For this problem, you're supposed to know that if the chords are the same, then you're supposed to add this here, and it becomes a perpendicular bisector. And you'll know all four of those pieces would be the same. All right? Problem number 9. You're supposed to know that the radius, you can move it like the hands of a clock. So literally, it would be here, and you would be doing right triangle work. A squared plus b squared equals c squared. Hopefully you know you would have a right triangle, and this is also a perpendicular bisector. So you know those measurements are the same on both sides. Okay? You know the radius is going to be your hypotenuse. Same thing here. You move it so that it's here, and then you do the right triangle work with this. Okay, hopefully you understand that this is cut into 2 equal pieces, so that means you need half of it, this and this, a squared, b squared, c squared. So that's the work I'm hoping to see. Okay, moving on. Problem number 11. Problem number 11. If the chords are equal, then the arcs are equal, the angles are equal, everything's equal. So hopefully you understand that. There we go. Problem number 12. Problem number 12 was the hardest problem on the test. Why? Because these chords are not equal. The chords aren't equal. But what will be equal for both of them? The radius would be equal. So I'm going to use the Pythagorean theorem to find the radius of one triangle. Then I'm going to use that radius for the other triangle to find the measure of this line segment here, x. Okay? So that means you'd be doing 2 right triangle problems. One, they're going to give you everything but the radius, and you're going to find it. Then you're going to do another right triangle, and the radius you found, you're going to put there, and you're going to find the missing side. Right? So it's 2 problems in one. This was the hardest. The problem most people have is they go, well, if the chords are then the numbers are all the same. No. If the chords are the same, then the numbers are the same. But these chords specifically are different. This one's 33, this one's 36. So none of these measurements are the same except for one, which is the radius. The radius will always be the same measurement because the radius never changes in a circle. So you'd have to do 2 triangles. One, you'll have all the sides but the radius. So then you do the Pythagorean theorem, find the radius. Then you plug the radius into the other one. You'll have a measurement here, and you'll have x, which is what you're missing, and solve for the other one. Okay. Here again, you're looking at this picture, and we know that if this is perpendicular, because that's what they told you, then this is a chord, and this has to be a diameter. Okay? Because the only time that that's going to be a perpendicular bisector is if it is a diameter. So that means that is bisected into equal pieces, which means these chords are equal, which means these arcs are equal. It's all sorts of stuff that is equal. Okay? All right, so let us move on to problem 14. Problem 14, hey, here we go. They ask us what is the measure of, they tell us that these are diameters, and this is where we draw the circle, put our points, and we know we're looking for a diameter because that tells us it's 180. So they want the measurement from Z to W to X. That's what ZWX is. They're looking for that measurement. And then they give you a diameter. So hopefully you know how to find that measurement. All right? All right, problem 15. Here you go. They've given you everything you need for the right triangle except put all the measurements on it. So they gave you the radius. You should know where it goes. Okay? You should know where OC is, and then you're doing a squared plus b squared equals c squared, and you're going to find that measurement. And then once you find that measurement, you turn around and you look at the question again, and you'll see that the question asks for the entire segment length, so you should know what you're supposed to do from that point on because it is a perpendicular bisector. Problem 16. Problem 16. Central angles and arcs are the same, but inscribed arcs are supposed to be half. Okay? So if this is 57, then the arc is 57, but that inscribed angle is half. All right, same thing with 17, the exact same concept. 18, the exact same concept, except you have a diameter in this picture. So like I said, you draw it out, you mark your arcs, here's your diameter. You should find what this measurement is, as well as what this measurement is, and this measurement, because your central angles and your arcs are congruent. Central angles and arcs are congruent. Central angles and arcs are congruent. It's inscribed, that's half. Okay? Same thing here. Central angles and arcs are congruent. So if I have a measurement here, that's called the central angle. If I have a measurement here, it's an inscribed angle. So this is half of the arc. When I throw it up, I multiply by 2. When I eat it, I divide it in half. You know, like chewing something up. Again, draw the circle, mark your arcs, put the measurements on there. Problem 19, exactly the same way. Draw the circle, mark your arcs, put the arc measurements that you have. So in other words, you would do something like this. There's 1 dot, 2 dot, 3 dots, 4 dots. Okay? So I put 4 dots on my picture. Then I'm looking for a diameter. So when I draw this diameter, I know that the top is 180 and the bottom is 180. Now there's 2 arcs here, but they're 180 and 180. Okay? Then I draw one angle at a time, and the first angle I'm going to draw is the one with the measurement. So I draw 53 degrees, and I know that's an inscribed angle. So then I find the arc, which is throwing it back up, multiply by 2. You've got 106. And then you can find the other piece, and then you work your way around the circle the same way. Only doing one angle at a time. Trying to find all the arc measurements. So you should be able to find this arc measurement, then you're going to be able to find that arc measurement. You're going to be able to work your way all the way around the circle. And you're also going to be looking inside the circle because central angles and arcs are the same. Okay, so here's a central angle, here's a central angle. So central angle and the arcs are the same. And then, of course, you know that C and B are a linear pair. So there's a lot of different ways that you should be doing this. It's not too difficult. Problem 21. Same concept. All right. Problem 22. Again, here's a radius. Touches here, forms a right angle. Okay. If they give you BY, you know what an inscribed angle is. It's swallowing it. And then, of course, you know that this angle here is formed a 90-degree angle because it's inscribed, which means this whole arc would be 180, but you know that because it's a diameter. And you're just adding, subtracting to find the other missing piece. Okay. 23, center of the circle. You have to write down the coordinate. Hopefully you know these are counting by 2, 2, 4, 6, 8. So if you're in between 2 and 4, you have to be the number 3, right? Okay. So it would be over 3 and down 2, 3, -2. And you should know that the numbers that go in the parentheses are always opposite. Okay. So if it's 3, -2, then the numbers you're going to put are -3 and +2. And then, of course, you count the radius. The radius here would be 1, 2, 3, and then you square it, which gives you right. Problem 24. Again, knowing about congruencies and segments that are congruent. If they're the same distance from the middle, then the chords are the same. The arcs are the same. Okay. You know that's a perpendicular bisector. Okay, pretty easy. 25, it's an inscribed angle. When you find the angle, how much of the arc is it? So here's the arc. What do you do to the arc? You divide it by 2. Hopefully you know that's the same as multiplying by what? Okay? Here we go. Problem 26. There's problem 26. Remember, you're rewriting the question and doing all this on your own paper. I'm just doing it on here so that you can kind of see what your work should look like. Again, being able to graph the point. This is back 2, 4, 6. So the point was -6, -2. Or, excuse me, -6, -1. Right? So that means they should both be positive when they're in the parentheses. And then the distance you just count. Okay? So that would be 2, 4. You square it. Okay? Same thing for all of these. These are relatively easy. You put them in the equation. Okay? This one, they already give you the radius. This one, you have to use the distance formula to find the radius, or common sense, one of the two. Either one will work to find the distance of the radius. Okay, and then last but not least, you have to be able to tell me the center and the radius from here, working backwards. Okay, and then of course, last but not least would be this one. All right. Any questions? Remember, you're picking that one from the multiple choice. So you would write down what the radius, the center is, and then what the radius is, and then find the matching picture. Okay? The center will help you tremendously narrow it down. Okay? All right. Good luck. Hopefully you do that, and you do the remediation assignment that's there as well, and you should be good to go to retake the test. All right, thank you very much. Remember, you have until the 22nd, because the 23rd I will not be here, I believe. Maybe I gave you a little bit longer. I may have given you the 29th. But if you look on Portal, you can see when you have to retake the test by. All right, have a great EOC review week.